Okay, for the next equation, we have 2x squared, y equals to 2x squared minus 12x plus 25. Like the last question, we'll like to extract information the easiest way, okay, by staring at it. So we know this is a parabola that's opening up. And also, we know that's a plus 25 as our c value. So our y-intercept is simply 0, comma 25. So I'm going to put a point right here and label this as 25. And make sure that you label all these points with numbers, okay? If you label the point but without the numbers, that's a wasted effort because nobody knows what you're talking, okay? Axis of symmetry, it's going to be negative b over 2a. So negative b over 2a, it's going to be, what is it? 12 over 4, which is 3. So x equals to 3. It's our axis of symmetry. And let me put a 3 right there and go ahead and draw the axis of symmetry. And without hesitating, I'm going to put the 3 straight to the x value of the vertex because I know they are going to be the same. Okay. And just like the last example, as we said, we have the equation. Okay, we have the equation. And we'll go ahead and find out the y value of the vertex since we've got the of the vertex. Okay, so y is equal to 2 times 3 squared minus 12 times 3 plus 25. And then 2 times 9, it's 18 minus 36 plus 25. And then I've got negative 18 plus 25, which is a plus 7. Okay, so 3 comma 7. So 3 comma 7, it's right here. And now, if the vertex is above the x-axis and it's opening up, and that's to cross 25, well, this would be the parabola. It has to be the parabola. And based on this parabola, what's the number of roots? There would be 0 real roots. And I'm going to go ahead and put a little appendix right here. It's called the 2 imaginary, okay, roots. 2 imaginary roots, which, well, we will find out in a moment. Okay, but since we've got the vertex at 3 comma 7, it's above the x-axis, so it's not going to cut the x-axis at all. Okay, so we're anticipating 2 imaginary roots, and let's see if we are correct. Okay, so negative b over negative b, sorry, plus or minus b squared minus 4ac over, okay, 2a. So you've got negative of negative 12, it's positive 12. And you've got 144. And then you've got 200. Okay, you got 200 over, then over, all over 2 times 2 is 4. So I think we do see a negative number underneath the square root, okay? Because 144 over 200, it's, sorry, 144 minus 200, it's negative 56. And let's see. I know 8 times 7. Oh, no, wait, hold on. 8 is not a good number. Let's say 4. 4 times 14. It's 56. I use 4 times 14 because 4 is a perfect square. So 2i root 14, that's how we simplify it. Okay. And then we can simplify this by 2. So we have 6 plus or minus I root 14 all over 2. Okay, so those are the roots that we have here. Okay. Now, one thing that you should also know is that for this pair of imaginary roots, we are not able to graph it. Okay, we are not able to graph it because the axes right here are real numbers. Okay, but the roots are imaginary, so we cannot see the imaginary roots right here. Okay, So don't worry about drawing them. We just need to find out that it's indeed, oh, sorry, hold on. I forgot to say over 2. That's bad. That's bad, right? So that's a huge mistake if I skip it. Okay. So yeah, so 2 imaginary roots right there. Okay. So that's pretty much it. All right. So for this example, what's new compared to the previous one is that we found out the vertex that happens to be above the x-axis. And since the graph is opening up, we have a pair of imaginary roots. We have 0 real roots. Okay, for this example. All right, next example would be number 3. All right, it's going to be something opening down because I can see the negative at the a value already. So let's go to the next video. Okay.